Welcome back. Now we will discuss half-lives. This becomes important in healthcare, pharmacy, nursing, because often we discuss drug life in terms of half-life. And what a half-life means is that in X amount of time, they'll tell you for each drug, it's very specific. This is half remains at this time. So, for example, I said that the half-life of this drug X is 1 hour. And so if we start with 1 gram of this drug, in 1 hour, 0.5 grams would remain. And another hour later, so 2 hours, 0.25 grams would remain. And then if we went out to 3 hours, 0.125 grams would remain. So it keeps getting smaller and smaller. It's a little curve like this until it becomes almost negligible. So how much remains? That's a common question. If you have 60 grams present, I'll give you a hypothetical, and they want to know how much remains after so many hours, and they have to tell you the half-life because, again, it's very drug-specific or element-specific if you're talking about a radioactive element. Then here's the equation. 1 over 2 to the n, where n is the number of half-lives that you will have, times the original mass. So this whole thing times the original mass. So what you would put in, because they say how much after 4 hours, this would become 4. The original mass that I gave you was 60. So let's see how much remains after 4 hours if the half-life is every 1 hour. So we put this in, 1 divided by, and I do parentheses, 2 to the 4, close parentheses, times 60, our original mass. 3.75 grams would remain after 4 hours. So just like memorizing the symbols for the different types of particles, it's good to memorize your half-life equation.